Yeah, so till yesterday, what we discussed was about the need of testing and the need of automation testing and what automation testing brings onto table and how it helps us in saving the cost and time and accuracy, improved accuracy, because humans can make mistakes. So we discussed these things yesterday. Any questions on this, what we discussed? Maybe you might have hearing the recording again and you might have had some doubts. You can ask now about what we discussed yesterday, right? So if not, then I will just continue. If you have something in between, either you can interrupt me in between, or you can also ping it on WhatsApp group which we have, or we have a chat as well in this Zoom session. So there you can also ping if you don't want to speak or interrupt me in between, right? So yesterday we discussed that what we need to get started is JDK and Eclipse. That was our most important two components without which you can't do anything, because rest everything what you see or hear, the libraries, tools, etc., they all run within Java. So we need to have an exposure or understanding with Java first, and to run execute Java we need a specific IDE, also called as integrated development environment, and that we have is in the form of Eclipse. So there are multiple IDEs available in the market. There are few which are paid. There are few which are free. Eclipse is completely open source, so most of the people use Eclipse. But we have one more which IDE which is relatively very good compared to Eclipse. It's called as IntelliJ, and this is also very good. So we can make use of this or we can make use of Eclipse, doesn't matter. More or less they remain same when it comes to the writing the code. Eclipse is also not that bad. It's just IntelliJ is better. uh, so we're going to focus mostly on our Eclipse thing. And yesterday we discussed that if you could download this JDK and Eclipse from internet and install it, that would be great, because from today onwards we are going to start programming. Basically simple small programs is what we're going to start with. So if you have done with it, fine. If you did not do it yet, you should do it. And to start with, you need Java 8. There are higher versions as well for Java, but you don't really need those versions. If Java 8 is enough, then Eclipse is what you need. So first you will download Java 8, install it, and then you install Eclipse. So it's like you have to go in sequence. Otherwise, it might break something will not work or something. Things you can land up in some issues. So it's always better to properly follow the steps. So first Java and then Eclipse. Now, when I say Java, it actually has few components. We need to first understand those components. What do we have in Java, broadly speaking? What are the components which are present there? For only then you will kind of understand the overall structure of Java and what you are downloading when you are saying I'm downloading Java, because Java allows multiple kind of downloads. So it could be a JDK, it could be a JRE. Like these are two different things and is used for different purposes. So I'm going to first talk to you about those things. All right. So maybe I will just share a window, a whiteboard basically, and kind of draw something there so that it makes more sense to you rather than just listening to words. Right. So if you can see a whiteboard, if you're not seeing, you can tell me. I'm drawing something now. So this is the topmost layer, you can say. I name it as JDK. Okay. So I can name it as JDK. JDK stands for Java Development Kit. Now, what this JDK is used for, if you want to develop something in Java, you need JDK. Okay. So when I said download Java, I actually meant download JDK. Okay. Now, inside this JDK, we have one more component called as JRE. So this is my JRE. It's also called as Java Runtime environment. Exactly. Cool. Good. So it's called a Java runtime environment. Now, how these two things are different or related is JDK is used when you want to write something and you want to convert it to a specific format so that it could be executed. JRE is used for execution. It doesn't convert anything with any. It doesn't convert source code to bytecode basically. It is used for execution. And inside this JRE, you can have another thing called as JVM, also called as Java Virtual Machine. JVM is Java Virtual Machine. Now, whatever you have, whatever Java code which you write, is actually gets executed inside JVM called as Java Virtual Machine. That is the biggest reason when we say Java is platform independent. It means the same Java code can get executed on different platforms because it doesn't bother on which platform it is running, because all of your Java code is actually running on JVM. So if you have Java environment with you, even if you install it on Mac, even if you have it on Linux, if you have it on Windows or any other operating system for that matter, as long as it has Java installed, the program which you wish to run on that machine will always get executed inside JVM. And that's what makes it platform independent. So it doesn't matter which machine you are making the software for, the same piece of code can execute on all the machines as long as it has Java installed, right? So how they are connected? JDK has JRE as well as JVM. JRE has JVM. So the idea is, if you want to write a source code like what you write here. So for example, if I just show you a simple example of the source code. So when you see this, okay, let me share my screen again by sharing my desktop. So when you see this code, you see English, right? You can read it. These are alphabets. These are keywords. There some are highlighted, but none. Essentially, these are English keywords. You can read it. This is called a source code. Now, source code will be kept inside a file called as something .java. So extension of that file will always be .java. It usually typically will be the name of the class file only. So this is a class. I'll talk about what class is. We'll come to that later. But the idea is the name of the class here will always be the name of the file here. So common here and common.java. Inside this, whatever you will have will be written in keyword formats. And this is a plain English format and you can understand it, right? That's what makes it a source code. So we call it a source code. Now the job of JDK is, JDK is a software, okay? It reads this source code, and after reading it, it converts it to a bytecode. Now, what is a bytecode? It's again Java defined terminology or format in which Java or JDK converts a source code written in English. It will convert it, and after converting it from source code, it will convert it to a bytecode. And that bytecode, to save that bytecode, it creates a file called as .class file. So it will be common .class file. So for when you actually write it, when you actually run it, so there will be two versions of the same code. One will be your common.java source code. Another will be common.class file, that is a bytecode. Okay. So let me first go back again to my whiteboard. So this JDK actually, what does it do? It actually converts, let me write it down here. So it actually converts source code to bytecode. Sorry, 1 minute. Right? Now what this JRE does, JRE executes that bytecode. So for execution purposes, JRE need bytecode, and this bytecode will be executed inside a JVM. Okay. Now, let me give you an example. Sometimes previously, or maybe still, you sometimes gets a pop-up, your Java, your JRE needs to be upgraded, your JRE needs to be upgraded, or your Java needs to be upgraded, right? So every machine usually should have JRE. Now, why we need it? Because there are few programs which needs JRE to be present in the system. Why? Because what what they execute is a bytecode. Okay, so for example, you are writing a code. So when you write a code, you need to compile it, right? So compiling means conversion of the source code to bytecode. This is what compilation is. Compilation simply means conversion of source code to bytecode. Now that activity is taken care by JDK. All right. Now, once that activity is over, you're no longer required to have JDK. So for example, you have done with the program, you're done with the software, and you want that software to be delivered to someone. That someone can be your client, it can be your colleague, or it can be your spouse laptop. You created something, you want that software to be executed on someone else's laptop or somewhere else. But to execute that software which you have created on your machine using JDK, to execute it, you really don't need JDK. To execute it, you need JRE, right? So JRE is used for execution of the compiled version of the Java code, right? That's why we need JRE. So when you actually install JDK, all you need is when you install, sorry, or when you install this JDK, JRE as well as JVM, everything comes with it. Let's say there is another person, he just wants to execute the code which you have done or created. For execution purposes, he will not install JDK. That person will always go and install JRE, because he doesn't need to develop it. He only needs to execute the already developed compiled code on his or her machine. So this is the basically primary difference between this JDK and JRE. Okay, any doubts so far on this?
I want to
Uh,
ask him something.
yeah.
Yeah. Java virtual machine is a one type of compiler, or uh,
So
is
don't, yeah, carry on.
so JVM is converting source code to bytecode or bytecode to machine code.
Uh, you can say it in that way, yes. So JVM is responsible for running the code. So when we say running the code, it actually has to run the bytecode which Java created, isn't it? So that bytecode actually doesn't mean anything to the system on the machine in which it's running, because machine work understands 0101 native languages, right? Assembly language, basically native language. So that conversion of bytecode to native language and executing it in the processor is done by JVM.
Okay.
Okay, but the compilation part is taken care by JDK. So first JDK will read the source code, it will compile it, convert it to bytecode, and that bytecode it will transfer to the JRE, and then JRE will transfer that to JVM, and then JVM will execute it. And while executing, it will do all the necessary things to for it this to be executed on a machine. So zero conversion of assembly language, native language, machine level language, all those things happen. And remember we have an OS as well here, right? So operating system actually does more things. So JVM actually talks to operating system perhaps and does all the computing. All right.
Yes. Yes.
Yeah,
Got it.
yeah, yeah. So we mostly focus on the JDK part because we want our code to be compiled, right? So let me just switch the screen again. Let me come back to my desktop. So let me show you something now. Okay. So I've told you about JDK, told you about JRE and all. But what we need to do next is to see how can we create a project, and how can we create a class, and how can we create a method, and what that method means, right? So I'll just take a very simple example, because as I said, I'm not very aware of how experienced you guys are or what is your background. So I'm just aiming for uh, from very fundamentals and basic. So I am, but still in this case, I'm assuming that you guys already have installed Eclipse. If you did not do it yet, you need to install it first, JDK, then Eclipse. Once you do this, you will get something of this sort. Maybe not at this sort, maybe you will get some welcome screen or something. You can cross that off. Then what you have to do next is, right now I'm trying to create a project here. Okay. So see how I'm creating the project, and you can imitate the same steps when you actually do it. So I'll go to file, I'll go to new, and I click on Java project. In case you're not able to see Java project here as a first item, you go to other, and you search for Java here. As soon as you do this, you get something here called a Java project. So it always has to be a Java project. Don't make this mistake of going to file new and creating a project. So you have to create a Java project. So once I create a Java project, once I click on it, I get this pop-up. And here I need to give a name to the project. So project name is, it can be anything for you. You can just say my first project, basically. Keep it simple. And here, depending on what version of Java you have installed, for example, I have installed the latest version. So I have Java 12 installed on my system, but I also have backward compatibility with it. So I can choose to select Java 1.8. That's what you can do as well. It doesn't harm to select Java SE 12, right? But what is bare minimum requirement is what I'm selecting here. So Java SE 1.8, or also called as Java 8. So don't get confused with 1.8. Sometimes this is called as Java 8, or sometimes people call it Java 1.8. Both are representing the same thing. Now this Java 8 I have selected here, and rest of the things you don't have to touch basically. So you can click on next, and here also you don't have to do anything. You just click on finish. As soon as you do this, you get a project here, and in my case you see lot many because I have lot many in my workspace, but for you it would be like the first only entry present inside package explorer. All right, if I open this, I get something here. Now this something is Jre System Library. If I expand this, this is all Java code here. Now these are the Java code which is available for us, and this is what is responsible for executing, compiling as well as executing our code. And Java comes with a huge library of its own to do many things. So you don't have to reinvent the wheel. Java comes with lot of things which you don't really have to worry about, and you can just make use of these libraries. For example, you want to do something with the file system. You want to read an Excel file, not Excel file, but file systems basically. You want to work with the database, right? So lot of things, lot of libraries, methods, classes are available here, existing with the existing compiler which we have. These libraries, they help us in doing a lot of things. For example, you want to save some data, lot of data. For that we have a collection library or collection API we call it, and that collection API, you can do many things with it. So you can store data, you can merge data, you can search data in there, you can remove data, you can loop it. So a lot of available features we have existingly available within these libraries. So you don't really have to do lot many things, and that's why when we created the Java project, these libraries were auto added here. So that simply means that this is the library which is available within the project, and then you can make use of these classes and their available methods to do your job. Then you will see a folder called as src. Src represents source here. So that means whatever you want to write, you have to write that inside src folder. So now what I'll do is I will create a package. Now what is a package? Package is a folder. That's all it is. If you see the structure of this project inside your workspace, in the folder structure of your system, you will see the folders being created. So for example, this Eclipse is pointing to a specific folder, right? We call that folder workspace. So maybe when you install Eclipse and when you open it for the first time, it will ask you for the workspace. A workspace is a place where all the project informations, all the project which you're going to create can be stored by default. When I say stored by default, it actually go and create a folder there. So I will show you basically where we have it. So for me, the workspace actually is here, Eclipse workspace new, and all the projects which you see there is arranged here in the folder structure. And you remember, I just created a project called as my first project. And if I open it here, I see two folders. One is bin, one is source. I'll talk to you about what bin is. Right now, bin is empty. And in source, it is also empty. Right now, I have bin and source, but here I'm only seeing src. I'll talk to you about the significance of these folders, but for now, let's keep it here as only, and I will just go and create my first package. So if I create my first package, I will give it a name, let's say com dot, let's say VisionIT finish. So as soon as I do this, it looks like com dot. So here dot represents a subfolder. You can read it as a slash. That means there will be a folder inside source named as com, and inside that we would have another folder called as VisionIT. So if I go back here, if you notice, previously it was empty, but now I have source com, and then inside that I have VisionIT because I have just created it. And if you see in the bin also the same structure is being followed, but since both of them right now are empty, so there nothing is displayed under these folders. Now what we do next is we will going to go and create a first class file, because in Java, as you few of you might be aware that it's called as object oriented programming, right? Also called as OOPS or OOP. Now the fundamental entity of this OOP or any language which supports this OOP is a class file. Idea is whatever code you want to write has to be present inside a class, and inside class we would have two main things. One is variables or instance variables, or and secondly methods. So a
Okay.
class is comprised of these two parts, variables and methods. All right. Sometimes people say can also say properties and methods, properties and functions. You can these word statements or words can be interchangeably used, but essentially a class have two sections. One is method, second is the properties. Now if I go here new and I create a class, it will ask me for a name. I'll say my first class, and here I will just select public static void main. I'll talk to you about the significance of this later. So as soon as I click on finish, I get a class being created here. At the top of the class, it's saying package com.visionIT. That means it's saying this class is present inside a package called as package com.visionIT, which is this. Inside that, the name of the class, public class, my first class. And if you notice, the name of the class which is coming here is also name of the file. Now let me go back to the folder structure. Now, if you can see here, as soon as as soon as I added a class in my Eclipse, it is being created here as a file. So my first class.java, and I can actually open it with any editor. So it is a text file. It's a source code. It can be opened in the text file. And if you can notice here in the bin folder, I have another class being created or another file being created, not class, another file being created with the same name of the class which I created. The name is same, but the extension is dot class here. All right. So this is what I was trying to tell you in the beginning, that this is the, the job of JDK is to convert source code, which is this. So this is your source code, to bytecode, which is this. So if I try to open it, perhaps somehow maybe from using some text edit software, which I have, sorry. So if I try to open this using the text edit software, it's not opening. So the idea is this text which you would see here, it will not be readable. It will not be in English format. It will be in a byte format. You cannot read it. It's a class file, or you can also say this is a compiled version of this. So when you compile this, the compilation process itself is actually conversion of source code to bytecode. Okay. Now this is not being displayed here. This is only being displayed at the folder structure level. This is being handled at the backend by Eclipse actually. Anyone wants to ask anything? Iqbal, you want to ask something?
No, it's clear.
Okay, cool. Uh, Now next is, let me tell you this, what this is. Okay. So now this is a class. Okay. Now inside this class, as I said, the class can have two things. Either it would have properties or it could have methods. So if I start writing something here, so I will write int a is equal to 2 and int b is equal to 5. Or rather, let me just break it like this: int a, int b, int c. So when I say write this, becomes my method. This becomes my instance properties or variables. Now what these are, so this is a variable whose type is int. That means the variable can store a data which has a type of int, means integer. So we have few different types of data types available, like default data types available in Java, and then we have different ways of generating our own data types, classes, objects. A lot of things are there. We're going to talk about it later. But if you are not very familiar with this, what this data type and what is a variable, maybe I will have to talk to you about it separately, and we need to do some basic foundational courses as well on how, what do we mean by this int and what is a variable. So you have to let me know if you're not very familiar on what these are. I'm assuming that you understand the variables concept here. Okay, so right now what I've done is a declaration. Declaration means I am declaring that I am going to use these variables. So in Java, you need to declare before you can use it. You cannot just use it without declaring. That is not the case with some interpreted language. For example, VB script or perhaps JavaScript. You don't have to declare a method. You can directly make use of it. But here in Java, it is strongly typed, and you cannot use a variable if you're not declaring it. So right now I've declared it here like this. Then the next thing I would do is A is equal to 5, B is equal to 7, and C is equal to A plus B. So basically what I'm trying to do here, is I'm trying to talk about this static, and also don't worry too much about it for now. So what I'm trying to do here, this is my declaration and this is my initialization. So these are two parts. I've divided. I could also have done it in a single step, but right now I'm divided into two to explain you what is declaration, what is initialization. This is declaration. When I assign a value, it becomes initialization. Then what I'm trying to do, really trying to do here is to add these numbers. So here A, B, C was declared. I am assigning A as 5, B as 7, and C is equal to A plus B. That means I am combining these two values here. Then I would like to print it. So I'll write system.out print ln. So this is the statement in Java which you can use to print a value, right? I'll say sum simply is C. Now my program is completed. As soon as I save it or when I run it, immediately this will get converted to my bytecode, and this bytecode will go inside the Jre JVM, and that will execute it. And once executed, whatever is the outcome, it will be printed. Now, how will I run it? Simply right click, run as Java application. Don't do it run on server, do Java run as Java application. And again, as soon as you do this, it will show you the result of the program. Sum is equal to 12 because I've added this. Okay, so today I tried to cover very basic thing about how would you start with the Java. So as I said, few of you might be finding it very basic because you guys are from computer background perhaps, and few of you would be, but I don't know if you kind of are very new to it. So if you're new to it, this is how you're going to proceed. You're going to install Eclipse and just try to create a simple program. And even though you have some background of Java, still try to create your first class and first method and try to play around. So don't just depend on what I am telling you to do. You can also go ahead if you have good exposure understanding of how the Java works. You can start creating your more programs. I can give you some assignments as well for you to try it on. But if you are not very familiar, then this is what you need to do first. So first you will do this, and then you will update me in the group that I have done this much. Or if you're not able to do this much also, then also you have to update me. I will help you out in, you know, moving you in the right direction. I'll guide you on how, where you're stuck. We have a team here who can help you in achieving that. Okay, so by this I'm going to end today's session. Again, I'm not going to extend it. We'll again meet tomorrow, and tomorrow I'm going to talk about more advanced programs relative to what I have discussed today. So maybe tomorrow we're going to talk more about classes, objects, how we'll initialize objects, how we'll create multiple classes with a basic, very simple basic explanation of maybe addition program or calculator program. So we'll try to create a calculator program which would have 4 methods, and we'll pass on information to those methods, and that will do our job basically. So that is what we'll try to focus on tomorrow. uh, any questions so far, guys? Anything which you want to talk about?
Akash, can you show us again that in shortly how you have created a package and how you have added the class?
Right, all right. So what I have done is I have right clicked here, right clicked on the source, go to new and create a package. So as soon as you create a package, you can give it any name. Doesn't matter what name you're giving. You don't have to do a dot and also you can directly create a package also. And after that, right click on the package, new and create a class. And you can give it any name again, finish, and the class will be created, right? Uh,
Right. Okay.
so you need to have this public static void main as well in the class. Only then you can execute some things. Whatever code you want to try with, you try it inside public static void main here. All right.
Okay.
Okay. If there is anything, you can ping in the group, and I will try to answer it. Okay.
Okay.
Okay. Thank you all. Bye.